Good day everyone, and welcome to our presentation. I'm excited to introduce our paper, Storydiffusion, Consistent Self-Attention for Long-Range Image and Video Generation, authored by Yupeng Zhou, Dequan Zhou, Ming Cheng, Jiaxi Feng, and Qibing Hu. Our research addresses the challenge of generating consistent images for storytelling and transitioning these images into videos in a training-free manner. Stay tuned as we delve into our novel method, Storydiffusion, and its potential to revolutionize image and video generation. Thank you. In this slide, we delve into the key highlights of our work. Our primary motivation is to generate consistent images for storytelling and transition these images into videos, all in a training-free manner. This is a significant step forward in the field of content generation. However, we acknowledge that our method, like others, has some limitations. For instance, there may be inconsistencies in minor clothing details, which is a common issue in current state-of-the-art methods. We're working on refining our consistent self-attention to address this. Another challenge we face is in generating very long videos. Our method is not specifically designed for this, and the absence of global information exchange can limit the length of videos we can generate. But rest assured, we're actively exploring ways to overcome this limitation in our future work. These key highlights underscore our commitment to advancing the field of content generation, while also acknowledging the challenges we face. We believe that by addressing these issues, we can make significant strides in our research. Begin frame. Frame title key highlights, begin itemize, item key insights, begin itemize, item we've developed Storydiffusion, a unique approach that generates consistent images and transitions them into videos, all without the need for training. This is a significant step forward in the field of storytelling. Item, we acknowledge that our method has some limitations. For instance, it may struggle with maintaining consistency in minor clothing details, and it's not yet optimized for generating very long videos. However, we're committed to addressing these issues in our future work. End itemize, end frame, On this slide, we're highlighting the key contributions of our work. We've introduced a novel method called Storydiffusion. This method leverages a mechanism we call consistent self-attention to generate images that are consistent in terms of the subject, and it does this without the need for training. Our approach is divided into two stages. In the first stage, we generate these subject-consistent images. In the second stage, we use these images to create consistent transition videos. This two-stage process allows us to generate high-quality, consistent visual content for storytelling. We believe this is a significant step forward in the field of content generation. Moving on to the key highlights of our work. The main idea revolves around generating consistent images and transitioning them into videos. We achieve this by incorporating a novel method called consistent self-attention into a pretrained text-to-image diffusion model. This allows us to generate images that maintain consistency in terms of character identity and attire, which is crucial for storytelling. Next, we create transition videos based on these consistent images. This is done using our proposed Semantic Motion Predictor. This predictor not only transitions these images into videos, but also enhances the narration of the story. In essence, our method, Storydiffusion, provides a new way to generate consistent images and videos for storytelling, offering a promising direction for future research in controllable image and video generation. Let's delve deeper into how this works in the following slides. Let's delve into the core of our method, Storydiffusion. As you can see in the figure, our approach involves generating subject-consistent images using a novel technique we call consistent self-attention. This technique is incorporated into a pre-trained text-to-image diffusion model. The process begins by splitting a story text into several prompts. Each prompt is then used to generate an image, and these images are processed in a batch. The magic happens when consistent self-attention steps in, building connections among these multiple images to ensure subject consistency. This means that the identity and attire of characters remain consistent across all images, which is crucial for effective storytelling. Our aim is to address the challenge of generating such consistent images and videos, and we believe Storydiffusion is a significant step in that direction. Let's delve deeper into the problem at hand. As you can see in this figure, our Storydiffusion pipeline is designed to generate subject-consistent images. This is crucial for storytelling, where maintaining consistency in character identity and attire is key. However, existing models often struggle with this task. Our approach is unique. We incorporate consistent self-attention into a pre-trained text-to-image diffusion model. The story text is split into several prompts, and images are generated using these prompts in a batch. The magic happens when consistent self-attention builds connections among these multiple images, ensuring subject consistency. This method allows us to generate images that not only tell a story, but also maintain the consistency of characters throughout the narrative. This is a significant step forward in the field of image and video generation for storytelling. Begin a frame. Frame title our solution. Story diffusion, begin a figure, centering, include graphics, width equals 0.8, text width, height equals 0.45, text height, SRC, task underscore execution, extracted underscore paper underscore data, 2405.01434v1, figures, 2405.01434v1 figure 3:1.png. Captiona tinea, the two-stage process of story diffusion. In the first stage, consistent self-attention is used to generate subject-consistent images. In the second stage, these images are transitioned into videos using the Semantic Motion Predictor. End of figure, begin itemize, item. Our approach, story diffusion, addresses these limitations by generating consistent images and videos for storytelling. Item. The core of our solution is consistent self-attention, which builds connections among multiple images for subject consistency. Item. We also introduce the Semantic Motion Predictor to transition these images into videos, enhancing the storytelling experience. End. Itemize, end frame, Let's delve deeper into our proposed method, story diffusion. This method is unique in its use of consistent self-attention to generate images and videos. As you can see in the figure, the pipeline of story diffusion is designed to maintain consistency in character identity and attire throughout the story. This is achieved by splitting a story text into several prompts and generating images using these prompts in a batch. The key here is the use of consistent self-attention, which builds connections among multiple images, ensuring subject consistency. This innovative approach allows us to generate images and videos that not only tell a story, but also maintain a consistent visual narrative. On this slide, we delve into the core of our method, story diffusion. The figure you see here illustrates the pipeline for generating subject-consistent images. This is achieved by incorporating our key improvement, consistent self-attention, into the pre-trained text-to-image diffusion model. The beauty of consistent self-attention is that it can replace the original self-attention in the diffusion backbone in a zero-shot manner. This means we can generate images that maintain consistency in character identity and attire without any additional training. We achieve this by splitting a story text into several prompts and generating images using these prompts in a batch. Consistent self-attention then builds connections among these multiple images, ensuring subject consistency. But we didn't stop there. To transition these consistent images into videos and enhance the story narration, we propose the Semantic Motion Predictor. This tool predicts transitions between two images in the semantic spaces, providing more stable results than predictions in the image latent spaces. In essence, our method allows for the generation of highly consistent images and videos that effectively narrate a story, all in a training-free manner. This is a significant step forward in the field of controllable image and video generation. Let's delve deeper into the pipeline of our proposed method, story diffusion. As you can see in the figure, the process begins with the incorporation of consistent self-attention into a pre-trained text-to-image diffusion model. This is a crucial step as it allows us to generate images that maintain consistency in character identity and attire, which is essential for storytelling. The story text is split into several prompts, and images are generated using these prompts in a batch. The magic happens when consistent self-attention builds connections among these multiple images, ensuring subject consistency. Now, why is this important? Well, we anticipate that this approach will outperform existing methods, especially when it comes to generating videos with complex transitions, such as large-scale character movements. This is a significant leap forward in the field, and we're excited to share more about it with you. On this slide, we delve into the core of our method, story diffusion. The figure you see here illustrates the pipeline for generating subject-consistent images. This is achieved by incorporating our unique consistent self-attention into a pre-trained text-to-image diffusion model. The process begins by breaking down a story text into several prompts. These prompts are then used to generate images in a batch. The magic happens when our consistent self-attention comes into play, building connections among these multiple images to ensure subject consistency. This means that the identity and attire of characters remain consistent across the images, which is crucial for storytelling. Now, let's shift our focus to a unique aspect of our method: transition video generation. Unlike traditional methods, Storydiffusion aims to generate videos with a given start frame and an end frame. This allows for a more controlled and precise video generation, which we believe is a significant step forward in this field. Stay tuned as we delve deeper into how this works in the following slides. In this slide, we delve into the core aspects of our proposed method. Firstly, we've designed our approach to be lightweight, aiming to minimize data and computational costs. This is a significant step forward in making advanced image and video generation more accessible and efficient. Secondly, our method is built to support long story generation. This addresses a key limitation of existing methods, which often struggle with generating longer narratives. Our approach uses a sliding window along the temporal dimension, allowing us to generate extended stories without excessive memory consumption. Lastly, we focus on the stability of results. Our method, Storydiffusion, predicts motions in the semantic space, which we found to generate more stable results than predictions in the image latent spaces. This stability is crucial for maintaining the consistency and quality of the generated images and videos. In summary, our method is lightweight, supports long story generation, and ensures stable results, making it a promising solution for controllable image and video generation. Moving on to related works in the field, we see that the realm of content generation has seen significant advancements, particularly in image and video generation. The potential of diffusion models in this area is immense, thanks to their rapid development. Now, let's delve deeper into diffusion models for image generation. These models have shown superior performance in generating high-quality images and videos. This is largely due to the use of extensive pre-training and advanced architectures. These elements combined have allowed diffusion models to outperform previous methods, setting a new standard in the field of content generation. In the next slides, we will explore how we can further enhance these models to generate consistent images and videos for storytelling. Stay tuned. Moving on to related works, we first look at the limitations of existing models. These models face challenges in generating subject-consistent images and videos. The IP adapter, for instance, provides strong guidance, but this often results in reduced control over the content that's generated. Next, we delve into identity preservation methods, such as Instant ID and PhotoMaker. These methods excel in maintaining identity controllability. However, they often fall short in ensuring consistency in attires and scenarios, which is crucial for a coherent narrative. In summary, while these methods have their strengths, they also have significant limitations, particularly in generating consistent and controllable content. This sets the stage for our proposed solution, Storydiffusion, which we'll discuss in the next slide. In our exploration of related works, we first look at the use of temporal modules for consistency. These modules are designed to maintain a sense of continuity between images or frames. However, they come with their own set of challenges, such as the need for extensive computational resources and large amounts of data. Next, we delve into transition video generation methods. Here, we have examples like sane and sparse CTRL. These methods rely heavily on temporal networks in the image latent space to predict transitions. While innovative, they often struggle with complex transitions, particularly those involving large-scale movements of characters. In our work, we aim to address these limitations and push the boundaries of what's possible in image and video generation. Stay tuned as we unveil our novel approach, Storydiffusion, in the next segment of this presentation. Let's delve deeper into the technical details of our proposed research, Storydiffusion. As you can see in the figure, Storydiffusion is a two-stage process. The first stage involves generating consistent images using a technique we call consistent self-attention. This technique ensures that the images generated are subject-consistent, which is crucial for storytelling. In the second stage, we transition these consistent images into videos. What's unique about our method is that it's training-free, making it efficient and easy to implement. So, in essence, story diffusion is a novel method that not only generates consistent images, but also seamlessly transitions these images into videos. This makes it a powerful tool for creating engaging and coherent visual narratives. Let's delve deeper into the technical details of our proposed research. Story diffusion. As you can see in the figure, our method is a two-stage process. In the first stage, we generate consistent images. This is achieved by using a technique we call consistent self-attention. It allows us to create images that are consistent in terms of the subject's identity and attire, which is crucial for storytelling. Moving on to the second stage, we transition these consistent images into videos. This is where our Semantic Motion Predictor comes into play. It predicts transitions between two images in the semantic spaces, creating a smooth and coherent video narrative. In essence, story diffusion is a novel method that combines the power of consistent self-attention and Semantic Motion Predictor to generate high-quality, subject-consistent images and videos. This approach opens up new possibilities for controllable image and video generation, which we believe will inspire future research in this field. Now, let's delve into the technical details of our proposed research. The key component of our method, story diffusion, is something we call consistent self-attention. This is a novel approach that allows us to generate subject-consistent images without any training. If you look at the figure on the screen, you can see the pipeline of story diffusion. But what does it mean to be subject-consistent? Well, imagine you're telling a story with images. You want the main character to look the same across all images, right? That's where consistent self-attention comes in. It builds connections among multiple images, ensuring consistency in the appearance of the subject, such as their identity and attire. This is crucial for storytelling, as it allows us to create a coherent narrative with images that are consistent and connected. In essence, consistent self-attention is the backbone of our method, enabling us to generate high-quality, consistent images for storytelling. Moving forward, let's delve into the technical details of our proposed research. As you can see in the figure, the pipeline of story diffusion is illustrated. The first step involves incorporating our novel consistent self-attention into a pre-trained text-to-image diffusion model. This integration allows us to generate images directly from story text prompts. The beauty of this approach is that it enables us to create subject-consistent images, which are crucial for effective storytelling. By splitting a story text into several prompts, we can generate a series of images that not only narrate the story effectively, but also maintain consistency in terms of character identity and attire. This is a significant step forward in the field of image and video generation, offering a new way to create engaging and consistent visual narratives. Let's delve deeper into the technical aspects of our research. The figure you see here illustrates the pipeline of our proposed method, story diffusion. One of the key components of story diffusion is the Semantic Motion Predictor. This component plays a crucial role in transitioning the generated images into videos. But how does it do that? It predicts the transitions between two images, but not in the traditional image latent spaces. Instead, it operates in the semantic spaces. This approach provides more stable results, enhancing the quality of the generated videos. In essence, the Semantic Motion Predictor is a game changer in the field of image and video generation, offering a more reliable and efficient way to create consistent and high-quality videos. This is just one of the innovative features of story diffusion, and we'll explore more as we move forward. Let's delve into the technical details of our research, specifically focusing on transition video generation. As you can see in the figure, our method, story diffusion, is designed to generate videos using a given start and end frame. This is a significant departure from traditional methods that rely on temporal networks and image latent space. Instead, story diffusion performs predictions in image semantic spaces, which allows for a more nuanced and accurate representation of transitions. This approach is particularly effective in handling larger movements, resulting in improved performance. In essence, story diffusion is a powerful tool that can generate high-quality, consistent videos for storytelling, providing a new avenue for content generation. Moving on to our proposed research and technical details, let's take a look at this figure which illustrates the pipeline of our novel method, story diffusion. Now, how does story diffusion stand out from existing approaches? Well, unlike other methods that rely on temporal networks in image latent space, story diffusion performs predictions in image semantic spaces. This key difference allows story diffusion to handle complex transitions, such as large-scale movements of characters with greater ease and accuracy. This is a significant advancement in the field, as it opens up new possibilities for generating more dynamic and realistic videos. So, in essence, story diffusion is not just about creating consistent images, but also about making the transition from images to videos more seamless and effective. On this slide, we delve into the technical details of our proposed research, story diffusion. As you can see in the figure, story diffusion operates in two stages. Initially, it uses consistent self-attention to generate subject-consistent images without any training. These images are not only applicable to storytelling, but also serve as input for the second stage. In the second stage, story diffusion creates consistent transition videos from these images. Let's illustrate this with an example. Imagine a story about a young man who spots a rose by the roadside, picks it up, and walks forward joyfully. Our method can generate images that consistently depict this story, maintaining the identity and attire of the character throughout. These images can then be transitioned into a video, providing a seamless visual narration of the story. This is the power of story diffusion, enabling us to generate consistent images and transition videos for storytelling. On this slide, we delve into the technical results of our research. As you can see in the figure, our story diffusion method has been successful in generating consistent images for storytelling and transitioning these images into videos. This is achieved through the use of our consistent self-attention mechanism, which ensures subject consistency in the images generated. We then create transition videos based on these consistent images, further enhancing the storytelling aspect. Our semantic motion predictor plays a crucial role here, enabling a smooth transition of images into videos. Our experiments have shown that story diffusion can handle larger movements, demonstrating its robustness and versatility. However, it's important to note that our method does have limitations, particularly when it comes to generating very long videos and maintaining consistency in minor clothing details. We are actively working on addressing these limitations in our future work. In summary, our story diffusion method opens up exciting possibilities for controllable image and video generation, and we look forward to seeing how it can be applied in various fields. On your left, you can see examples of images and videos generated by our story diffusion method. This demonstrates our method's unique ability to create consistent images for storytelling and transition these images into videos. Now, let's delve into the implications of our results. Firstly, story diffusion can generate images and videos with consistent characters in terms of identity and attire, maximizing user controllability. This is a significant step forward in the field of image and video generation. Secondly, our method can generate subject-consistent images for storytelling. This is achieved by incorporating our consistent self-attention into the pretrained text-to-image diffusion model. Thirdly, we can generate long stories by implementing consistent self-attention with a sliding window along the temporal dimension. This allows for a smooth transition between images and a coherent narrative. Lastly, our semantic motion predictor can predict transitions between two images in semantic spaces, yielding more stable results than predictions in image latent spaces. This ensures a smooth and natural transition between images in the generated videos. In summary, our story diffusion method offers a novel approach to image and video generation, providing a more consistent and controllable output. Begin our frame. Frame title our method in detail. Begin itemize. Item our approach. Begin itemize. Item we divide our method into two stages. In the first stage, we use consistent self-attention to generate subject-consistent images. These images are then used as input for the second stage. Item in the second stage, we create consistent transition videos from these images using our story diffusion method. End itemize. Item an example story. Begin itemize. Item to illustrate. Consider a story of a young man walking down a road, spotting a rose, and picking it up. We split this story into several prompts and generate images using these prompts. Item, our consistent self-attention builds connections among these images, ensuring subject consistency. End itemize, end iframe, backquote.